All right, we're going to go over the homework that I assigned you yesterday, and then we're going to move on to naming and putting compounds with polyatomic ions together, and then we're going to do that with covalent, and that's going to end the naming part of this, which will be the end of the information you need to know for the quiz. All right, so let's start here. K2O. K2O is potassium oxide. ZNO, zinc oxide. SRS, strontium sulfide. Calcium sulfide. Silver sulfide. Zinc fluoride. Silver nitride, sodium fluoride, barium oxide, sodium sulfide, aluminum bromide, lithium nitride, potassium fluoride, strontium iodide, magnesium oxide, aluminum oxide, and calcium hydride. Now, the part that I'm going to spend more time on is writing the compound out, because that requires a little bit more work in terms of you have to look up your ions. So zinc is always +2, iodine is -1. You crisscross them, you're going to get zinc iodide. By crisscross, I mean you're going to use the charges as the subscripts. Magnesium nitride. Magnesium is +2. Nitride is -3. Crisscross, and you would end up with magnesium 3N2. Calcium hydride. Calcium is +2. Hydrogen -1, because it's in hydride form. And so you get calcium hydride with an H2. Potassium phosphide. K is +1. Phosphide is -3. So you get K3P. Calcium fluoride is CaF2. Sodium nitride is Na3N, because N is -3 and Na is +1. Magnesium chloride is MgCl2. Calcium chloride, CaCl2. Potassium iodide, Ki. Aluminum chloride, AlCl3. Barium chloride, BaCl2. Sodium chloride, NaCl. Silver bromide. Silver is one of those transition elements that always has one kind of charge, which is +1. So bromide is -1. Silver bromide is AgBr. Magnesium hydride, MgH2. Again, magnesium is a group 2 metal, +2. Hydride is -1. Zinc chloride. Again, Zn is one of the transition metals that's always +2. And then zinc sulfide is ZnS. So that's the way we're going to name the binary compounds and put them together. Now, the ones that we talked about, Roman numerals, it makes it a little easier, because with the Roman numerals, so let's say we have copper, and then we put in parentheses 2 chloride. So we look for chloride in terms of what that charge is, but copper, since it has the Roman numeral, automatically we know the charge of copper. So copper is +2, that's what the Roman numeral 2 indicates. Chloride is Cl -1. We know that, well, first because we have a table that tells us that. Also, chlorine is a group 17 halogen, and it likes to gain an electron. So when we put these together, it's going to be CuCl2. Now, when you're going backwards, in other words, you have this and you want to name it. So how do you know copper is +2? By looking at it, you know chloride is -1 and it has a 2. That's how you come up with the Roman numeral to come up with this compound. Okay, let's try another one. let's say we have iron 3 sulfide. So this 3 indicates the charge of iron. So it's Fe plus 3. Sulfide we know is a group 16 element, so it's 2 minus. And so when we put them together, we're going to crisscross these charges. So it's going to be Fe2S3. So you do the opposite if the compound is given and you want to name it. So you're going to say iron, and then to determine the Roman numeral, you're going to look to see what the ratio is and what the charge is. You'll have to remember sulfur is 2 minus. There are 3 of them, so that gives you -6. Each iron must be +3, and that's how we end up with 3 here, and the sulfide is sulfide. Okay. So let me give you a few to do on your own. Iron 2 side. All right, so for those of you who have forgotten Roman numerals, V is a 5. So vanadium 5 chloride. And copper 1 nitride. Okay, so go ahead and pause. Do these on your own. And then come back, unpause, and see the solution. All right, so hopefully you went ahead and paused and solved these. So Fe2, Fe plus 2, oxide is O2 minus. So this is going to give me FeO, right? Because it's a 1-to-1 ratio. Vanadium plus 5, chloride minus 1. So it's going to be VCl5. Copper 1, nitride is -3. So it's going to be Cu3N. Okay. Now let's try the exact opposite of that. In other words, you have the compound and you need to name it and you need the Roman numerals. So let's try this. Let's say we have Cl2. And let's try chromium I3. Okay, do the same thing you did a little bit ago. Go ahead and pause it and then solve those 3 and then come back to see the solution. All right, so hopefully you did that. Let's look. Copper chloride. Okay, we know that part. It's copper and it's chloride. Now for the Roman numeral, we know chloride is -1, there are 2, so we just put a 2 there. Fe2S3, so which means in order for this to happen, it looked like this, right? So then I know this is iron 3 sulfide. Same thing here, it's Cri3. I know iodine is -1. There are 3 of them, so it is chromium. Once again, 1, 2, 3, iodide. Okay? So the next kind of naming has to do with polyatomic ion. So let's first define what a polyatomic ion is. Polyatomic ions are a group of atoms covalently bonded with an overall charge. So you get the list of polyatomic ions. You don't have to memorize them, along with the charges. So what is an example of one? So it'll look like this, NO3, and it'll have a minus. This minus charge belongs to this entire compound. The nitrogen and the oxygen are covalently bonded together. And now the name of this compound, or the polyatomic ion, is nitrate. This minus one belongs to this whole compound, so we treat it as an ion when we're putting the compound together. So for example, if I had calcium nitrate, so I know what calcium is, that's +2. Now I told you what nitrate is, and you'll have a chart with a -1. That minus doesn't belong to just oxygen or nitrogen, it belongs to the whole thing. So when I put it together, it's going to be calcium. I'm going to open parentheses and put NO3 in there and put a 2 outside to indicate that there are 2 NO3s per calcium, okay? Because again, I need to account for that -1. That -1 belongs to this entire compound. And since calcium is +2, then I need to have 2 of the -1s in order to cancel out, because again, it is a neutral compound at the end. And you're going to see most, not all, but most of the polyatomic ions end in -ate or they end in -ite. So this is a list of polyatomic ions that you'll be given. It's also, there's a link on the calendar that you can click on in order to, and you will use it on the test. You'll actually have a copy of this on the test. So as you can see, a lot of them end in -ate and -ite. There are a few here and there that end in -ide, but we're going to use, there are ones that are very common, like the sulfate and sulfide and phosphate and nitrate, nitrite, that you see a lot more than the other ones. There's only one positive one, and that's ammonium. That's right here, NH4+. So how do we put them together with other ions? Is we're always going to have a metal in front of it. So it's going to be, let's say, magnesium, let's say chlorite. Okay, so we go and find chlorite on the table. We see that it's ClO2 with a -1 charge. We already know about magnesium because it's a group 2 element, right? So magnesium is 2+, chlorite is -1. So that means I need 2 chlorites. Remember, I'm taking this as an entire unit. Think of it as one thing. So I'm going to put magnesium, and then I'm going to put the chloride in parentheses. If it makes it easier, just put all the polyatomic ions in parentheses. It'll just make it a little easier for you to always remember. And then you just put a 2 outside. That 2 belongs to this entire compound. So since the entire compound has a charge overall, it's not just the chloride, it's not just the oxide that has that -1, it's the entire thing that has the -1. So by putting a 2 outside, you're indicating there are 2 times -1 with magnesium, which is a 2+, so 2 plus -1. Again, you go back to that neutral compound. So what if we had something like, let's try this one. Let's say we have sodium carbonate. Okay, we know sodium, that's Na, we know it's +1. Now we go and find carbonate, and as you can see, it's CO3, and it has a 2- charge. So now we need Na, we need 2 NAs, since that's +1 and -2, right? I need 2 pluses to cancel out the 2 minus, and it's CO3. Now you can always put the CO3 in parentheses or not. In this case, since there's only one of them, you don't need a parentheses, but it is not wrong if you put it in parentheses. So I'm going to give you a few to do on your own. And then there's also a worksheet with polyatomic ion practice, naming and writing compounds. There's a link to it, and you'll get a hard copy as well if you need it. And that will be due for next class, which is Monday. All right, so let's do a few examples. Let's say we have lithium bromate, calcium hydroxide, and all of these are on the table. So you're not memorizing bromate, you're not memorizing hydroxide, they're all on the list of polyatomic ions that you have. And let's say we have potassium perchlorate. Okay, so all we do is go back to that table, the one that I just showed you that you have a link to. So you find bromate. So here it is. Let me pull up the table. Okay, so you go and find bromate. You see it's BrO3, right, with a -1 charge. Okay. So BrO3 -1. Okay, you know lithium is +1, so +1 -1 is just going to add up to lithium bromate. Calcium hydroxide, Ca is 2+. Hydroxide is one of those that actually ends in IDE, but you see how it's hydroxide, it's actually hydrogen and an oxygen together. It has a -1 charge, so you're going to have 2 of the OHs, so you have to now put them definitely in parentheses and put a 2 outside. And potassium perchlorate. Perchlorate, again, is you see the 8, and you know automatically it's a polyatomic ion. You look at the table, and you're going to see that it's ClO4 with a -1. Potassium is K+. You put them together, and you're going to get KClO4. Okay? All right, so there's a link, worksheet link on the calendar that you have access to on MyJag, and it's under the assignments 11-17. You're going to complete that now. You obviously can use your periodic table along with the tables that you have, and once you complete it, submit it, and that's due by Monday. All right, have a wonderful weekend.